Aviation safety. Incipit. Aviation safety is a term encompassing the theory, investigation, and categorization of flight failures, and the prevention of such failures through regulation, education, and training. It can also be applied in the context of campaigns that inform the public as to the safety of air travel. Institutions. United States. During the 1920s, the first laws were passed in the USA to regulate civil aviation. Based on the current numbers flying, this would equate to 7,000 fatal incidents per year. The fatal incident rate has declined steadily ever since, and since 1997 the number of fatal air accidents has been no more than 1 for every 2 billion person-miles flown, and thus one of the safest modes of transportation when measured by. The World Bank has published the reliable data of the frequency of passengers carried by air transport in the year 2012 obtained from the International Civil Aviation Organization, 756,617,000 cf. The United States had an international flight frequency of 9,560,451 in 2012. The main cause is pilot-in-command error. Between 1990-2006, there were 1441 commuter and air taxi crashes in the U.S., of which 373 were fatal, resulting in 1,063 deaths. Alaska accounted for 513 of the total U.S. crashes. Another aspect of safety is protection from attack, currently known as security and intentional causes of harm or property. However, even if they were counted as accidents, they would have added about 2 deaths per 2 billion person-miles. Even so, the rate that year, including the attacks, is safe compared to some other forms of transport when measured by distance traveled. Safety has improved from better engineering and maintenance, the evolution of navigation aids, and safety protocols and procedures. The number of deaths per passenger mile on commercial airlines in the United States between 2000 and 2010 was about 0.2 deaths per 10 billion passenger miles, while for driving, the rate was 150 per 10 billion vehicle miles for 2000. Aviation safety hazards. Ice and snow. Ice and snow can be major factors in airline accidents. In 2005, Southwest Airlines Flight 1248 slid off the end of a runway after landing in heavy snow conditions, killing one child on the ground. Even a small amount of a coarse frost can greatly impair the ability of a wing to develop adequate, which is why regulations prohibit ice, snow, or even frost on the wings or tail prior to takeoff. Air Florida Flight 90 crashed on takeoff in 1982, as a result of ice, snow on its wings. An accumulation of ice during flight can be catastrophic, as evidenced by the loss of control and subsequent crashes of American Eagle Flight 4184 in 1994, and Comair Flight 3272 in 1997. Both aircraft were turboprop airliners with straight wings, which tend to be more susceptible to in-flight ice accumulation than are swept-wing jet airliners. Airlines and airports ensure that aircraft are properly before takeoff whenever the weather involves icing conditions. Modern airliners are designed to prevent ice buildup on wings and tails by either routing heated air from jet engines through the leading edges of the wing and inlets, or on slower aircraft by use of inflatable rubber that expand to break off any accumulated ice. Airline flight plans require to monitor the progress of weather along the routes of the flights, helping to avoid the worst of in-flight icing conditions. Aircraft can also be equipped with an ice detector in order to warn pilots to leave unexpected ice accumulation areas before the situation becomes critical. Pitot tubes in modern airplanes and helicopters have been provided with the function of pitot heating to prevent accidents like Air France Flight 447 caused by the pitot tube freezing and giving false readings. Aviation safety hazards. Fire. Safety regulations control aircraft materials and the requirements for automated fire safety systems. Usually these requirements take the form of required tests. The tests measure of materials and toxicity of smoke. When the tests fail, it is on a prototype in an engineering laboratory rather than in an aircraft. Fire and its toxic smoke have been the cause of accidents. An electrical fire on Air Canada Flight 797 in 1983 caused the deaths of 23 of the 46 passengers, resulting in the introduction of floor-level lighting to assist people to evacuate a smoke-filled aircraft. In 1985, a fire on the runway caused the loss of 55 lives, 48 from the effects of incapacitating and subsequently lethal toxic gas and smoke in the British Air Tours Flight 28M accident, which raised serious concerns relating to survivability, something that had not been studied in such detail. A swift incursion of the fire into the fuselage and the layout of the aircraft impaired passengers' ability to evacuate, with areas such as the forward galley area becoming a bottleneck for escaping passengers, with some dying very close to the exits. Much research into evacuation and cabin and seating layouts was carried out at Cranfield Institute to try to measure what makes a good evacuation route, which led to the seat layout by overwing exits being changed by mandate and the examination of evacuation requirements relating to the design of galley areas. The use of smoke hoods or misting systems were also examined, although both were rejected. South African Airways Flight 295 was lost in the Indian Ocean in 1987 after an in-flight fire in the cargo hold could not be suppressed by the crew. The cargo holds of most airliners are now equipped with automated fire extinguishing systems to combat a fire that might occur in the baggage holds. In May 1996, ValueJ Flight 592 crashed into the Florida Everglades a few minutes after takeoff because of a fire in the forward cargo hold. All 110 people on board were killed. At one time, firefighting foam paths were laid down before an emergency landing, but the practice was considered only marginally effective, and concerns about the depletion of firefighting capability due to pre-foaming led the United States FAA to withdraw its recommendation in 1987. One possible cause of fires in airplanes is wiring problems that involve intermittent faults, such as wires with breached insulation touching each other, having water dripping on them, or short circuits. These are difficult to detect once the aircraft is on the ground. However, there are methods, such as spread spectrum time domain reflectometry, that can feasibly test live wires on aircraft during flight. Aviation safety hazards, human factors. The airplane is a Boeing 720 testing a form of jet fuel, known as antimisting kerosene, which formed a difficult-to-ignite gel when agitated violently, as in a crash. Human factors, including pilot error, are another potential set of factors, and currently the factor most commonly found in aviation accidents. Much progress in applying human factors analysis to improving aviation safety was made around the time of World War II by such pioneers as Paul Fitts and Alphonse Chapanis. However, there has been progress in safety throughout the history of aviation, such as the development of the pilot's checklist in 1937. CRM, or crew resource management, is a technique that makes use of the experience and knowledge of the complete flight crew to avoid dependence on just one crew member. Pilot error and improper communication are often factors in the collision of aircraft. This can take place or on the ground. Aviation safety. Incipit. Aviation safety is a term in aviation safety hazards. Piloting while intoxicated. Rarely, flight crew members are arrested or subject to disciplinary action for being on the job. In 1990, 3 Northwest Airlines crew members were sentenced to jail for flying while drunk. In 2001, Northwest fired a pilot who failed a breathalyzer test after a flight. In July 2002, both pilots of America West Airlines Flight 556 were arrested just before they were scheduled to fly because they had been drinking alcohol. The pilots were fired and the FAA revoked the pilot licenses. At least one fatal airliner accident involving drunk pilots occurred when Aero Flight 311 crashed at Kauhajoki, Finland, killing all 25 on board in 1961, which underscores the role that poor human choices can play in air accidents. Human factors incidents are not limited to errors by pilots. Failure to close a cargo door properly on Turkish Airlines Flight 981 in 1974 caused the loss of the aircraft. However, design of the cargo door latch was also a major factor in the accident. In the case of Japan Airlines Flight 123, improper repair of previous damage led to explosive decompression of the cabin, which in turn destroyed the vertical stabilizer and damaged all 4 hydraulic systems which powered all the flight controls. Aviation safety hazards. Volcanic ash. Plumes of volcanic ash near active volcanoes can damage and cockpit windows. In 1982, British Airways Flight 9 flew through an ash cloud and temporarily lost power from all 4 engines. The plane was badly damaged, with all the leading edges being scratched. The front windscreens had been so badly sand-blasted by the ash that they could not be used to land the aircraft. Prior to 2010, the general approach taken by airspace regulators was that if the ash concentration rose above 0, then the airspace was considered unsafe and was consequently closed. Volcanic ash advisory centers enable liaison between and the aviation industry. Aviation safety hazards. Terrorism. Aircrew are normally trained to handle situations. Since the September 11, 2001 attacks, stricter and airline security measures are in place to prevent terrorism, such as security checkpoints and locking the cockpit doors during flight. Aviation safety hazards. Foreign object debris. Foreign object debris includes items left in the aircraft structure during manufacture, repairs, debris on the runway, and solids encountered in flight. Air France Flight 4590 crashed after hitting a part that had fallen from another aircraft. Aviation safety hazards. Bird strike. Bird strike is an aviation term for a collision between a bird and an aircraft. The weight and numbers of birds that can be ingested without hazarding the safe flight of the aircraft are related to the engine intake area. The outcome of an ingestion event and whether it causes an accident, be it on a small, fast plane, such as military jet fighters, or a large transport, depends on the number and weight of birds and where they strike the fan blade span of the nose cone. Some airports use active countermeasures, ranging from a person with a shotgun through recorded sounds of predators to employing passive countermeasures involve sensible land use management, avoiding conditions attracting flocks of birds to the area. Fatal accidents have been caused by both engine failure following bird ingestion and bird strikes breaking cockpit windshields. Jet engines have to be designed to withstand the ingestion of birds of a specified weight and number and to not lose more than a specified amount of thrust. Aviation safety hazards. Pilot fatigue. The International Civil Aviation Organization defines fatigue as a physiological state of reduced mental or physical performance capability resulting from sleep loss or extended wakefulness, circadian phase, or workload. The phenomenon places great risk on the crew and passengers of an airplane because it significantly increases the chance of pilot error. These factors can occur together to produce a combination of sleep deprivation, circadian rhythm effects, and time-on-task fatigue. Experts in aviation fatigue often find that these methods fall short on the goals. Aviation safety hazards. Ground damage. Various ground support equipment operate in close proximity to the fuselage and wings to service the aircraft and occasionally cause accidental damage in the form of scratches in the paint or small dents in the skin. During ground services, a baggage handler hit the side of the aircraft with a tug towing a train of baggage carts. This damage was not reported and the plane departed. The cabin depressurized explosively, necessitating a rapid descent to denser air and an emergency landing.